Hi, my name is Pablo and I am a second-year PhD student at the Music Technology Group working with music classification with a focus in generalization. Music classification consists of predicting classes from a taxonomy given the input audio signal. The typical music classification taxonomies include musical genres, instruments, and moods. However, despite advances in the fields of machine learning and deep learning, music classification still remains a challenging task. Some of the main reasons are the difficulty to create public datasets because of the problems attached to the music copyrights, the musicological knowledge required to produce new annotations, the density of the audio signals that make them naturally more expensive to store and process compared to signals such as images or natural text, and the subjectivity of certain classes. For example, happy music would mean something different for two people with different cultural backgrounds. Because of these reasons, we are commonly facing scenarios where only small datasets are available. This normally leads to poor classification performance. Because of this, transfer learning has become very popular in the recent years. In a typical transfer learning scenario, the knowledge acquired by a larger pre-trained model is leveraged for the target application, normally allowing to improve significantly the performance. However, we can easily identify problems in the popular datasets used for transfer learning in music classification. For example, some of them are too small, very noisy, or not specific for music. Because of this, we propose leveraging the metadata available from the Discogs to create a new dataset. Discogs is a website that contains a crowdsourced database of information about music recordings. It's created by an active community and it contains a taxonomy of more than 500 music styles. Music styles could be seen as a fine-grained version of genres including cultural and regional aspects. Furthermore, this metadata is available under Creative Commons license. We matched the Discogs metadata against the MTG in-house audio collection and obtained a dataset of 3.3 million tracks with the style labels suitable for training. After a great search over models, we selected an efficient CNN for our evaluation. We evaluated our model in a transfer learning setup and compared it to 5 state-of-the-art music and audio embedding models. In this table, we only show the 2 best models that we found. Our efficient net was able to overcome the state-of-the-art predicting genres and the 50 most popular tags of the MTG Jiménez dataset, despite being 10 times smaller in parameters than the BGG's model. Finally, we were interested in assessing the influence of the considered embeddings on the generalization capabilities. First, we trained shallow classifiers using small datasets and got metrics from the test set. After this, we used those classifiers to make predictions for an external dataset with the same labels but slightly different types of music in it. This experiment allowed to understand how different embeddings contribute to reduce the generalization gap. However, this research is part of an ongoing project, so the results are not public yet. If this project sounds interesting for you, you can contact me by email or Twitter. Thank you very much for your attention.